Hey, it's Mr. Lum again, and today we're going to be talking some more acid and base chemistry and looking at hydrolysis. And what exactly is hydrolysis? Well, hydrolysis is when a salt reacts with water and the anion or cation produces an acidic or basic solution. And we're going to talk about what that means. So, first off is sometimes you can have a salt in water and the anion or the cation is going to be producing an acidic or basic solution. So let's take a look at some different, an example of this. So an example of this could be something like, say, NaF. Okay, so when NaF dissolves in water, it's going to become Na plus and F minus. Well, this F minus, okay, this F minus can combine with water and produce HF and OH minus, okay? So, in other words, NaF is going to eventually produce some OH ions, and therefore it is a basic salt, okay? Because that F minus is going to combine with water and produce hydroxide ions. Now, what about the Na? Now, why didn't this do anything? Well, Na is just a spectator. It's a spectator cation. Spectator cation. Now, all spectator cations are from column 1 and column 2 of your periodic table. So, here is column 1 of the periodic table, these ones right here. Okay? And here's column 2 of the periodic table. Okay, so whenever you have like lithium, sodium, or potassium, or any one of these ones, or like calcium, magnesium, they're just going to be producing neutral solutions. They're spectators. They're not going to be combining with water to form any kind of OH, or they're not going to be combining with water to form any kind of H3O+. Okay, so right here we see sodium. And this was one of these ones. So sodium right here was a spectator cation. Okay. Now, a spectator anion is something that is the anion of a strong acid. So let's take an example like chlorine right here. Okay. So if we have another example like NaCl. Okay, that's going to produce, when dissolved in water, it's going to produce Na plus and Cl minus. Now, we already talked about how Na is a spectator cation. Okay, now Cl is going to be a spectator anion because Cl cannot combine with water. It will not combine with water. It will not make HCl. Because HCl only goes in this forward direction. It does not have a reverse direction here. 100% of HCl ionizes, and therefore it only goes in this forward direction. Cl cannot combine with H and go in the reverse direction. So that is why Cl minus is a spectator anion. Okay? And therefore, Na is a spectator, Cl is a spectator, and that's going to be a neutral salt. But we'll talk a little bit more about that later. Okay, so again, all of the spectator anions are these ones right here. These are all spectator anions. Actually, I kind of made a bit of a mistake, but ClO4 is a spectator anion, I, Br, Cl minus, NO3 minus, they're all spectator anions. Now, this one right here is an exception. It is not a spectator, because if we went further down on this acid-base chart, we would see that HSO4 minus is also a weak acid. Okay, so this one is an exception. This one is not a spectator anion. Okay, but these 1, 2, 3, 4, 5 are spectator anions. Okay, now let's take a look at some different types of salts and figure out if they are acidic salts or basic salts, or if they're neutral salts. Okay, here is KBr. Okay, and KBr is dissolved in water. Now, when KBr dissolves in water, it's going to produce K plus and Br minus. Now, K plus, if you remember your periodic table that we just looked at, this is from column 1. Column 1. Okay, so in other words, this is a spectator. Okay, now Br, well, Br is the anion. This is the anion. Anion of strong acid. It's the anion of a strong acid, and that strong acid is HBr. Okay, so this one is also a spectator. Okay, so we have two spectator ions here. So K is not going to combine with water, Br is also not going to combine with water, and therefore when KBr is dissolved in water, it's going to produce a neutral solution. Okay, so again, that just means the pH is going to stay neutral, okay, or pH 7. Now let's take a look at this one right here. NaIO3. NaIO3 is going, when it's put into water, is going to dissolve and make Na plus and IO3 minus. Now, this one is also column 1. Okay, and therefore is a spectator. Okay, now IO3, well, if we looked up, I took a little bit of the table there, and we see that IO3, well, it's weak. Okay, it's not from a strong, it is not the anion from a strong acid. It is the anion from a weak acid, or in other words, it itself is a weak base. Okay, so what's going to happen is that IO3 is going to combine with water because it is dissolved in water, and therefore it is going to produce HIO3 and OH minus. Okay, and therefore, since it's making OH minus, it makes OH minus, this is a basic solution. After it is dissolved, after NaIO3 dissolves, it's going to produce a basic solution. So what we can say is that NaIO3 is a basic salt. Okay, this is a basic salt. Okay, so this is what we can say is this is a basic salt. Okay, because at the end, when it's dissolved in water, it's going to produce a basic solution. Now let's take another look at this one right here. We have NH4Br. Again, Br Br is an anion of a strong acid, and that strong acid comes from HBr, which is, if you look on your table, HBr is a strong acid, and therefore it is a spectator. Okay? Now this one is not a spectator. This one, if you look on our list right here, it's, NH4 is right here. Okay? And it is going to, when NH4 plus ion is in water, what's going to happen is that it is going to combine with water and produce H3O plus and NH3. Again, since it makes H3O plus, it is a acidic solution. Okay? And therefore, NH4Br is a acidic salt. This is an acidic salt. This is a basic salt, and this one is a neutral salt. Okay? Now, next video we're going to look at what happens if you have something that is amphiprotic and it's dissolved in water, and also too, we're going to take a look at what happens if you have something like NH4IO3. One is acidic and the other one is basic. Okay, and which one is it going to be? Is it going to turn into a basic solution, or is it going to turn into an acidic solution? And we're going to look at that, and it involves a small calculation. Okay, next time.